Most robotic systems employ one of two kinds of machine learning. In exploratory algorithms, the agent explores the state space of the problem exhaustively or heuristically to build a model of the world. One shortcoming of this approach is that it often takes vast numbers of trials to generalize what is learned. In instructed or tutelage-based learning, a human teacher teaches the robot specific tasks. This accelerates the learning process and allows the human to decide what the robot should learn. However, a shortcoming of this approach is that the robot learner often does not explore on its own and can only learn what is explicitly taught. In this video, we present a novel approach called socially guided exploration that uses both an exploratory and a tutorial approach to complement the strengths and mitigate the shortcomings of each learning technique. The robot, Leonardo, learns about a puzzle box in front of him. The box includes a slider, a switch, a button, 5 lights, and a lid. To open and close the box, the slider, the switch, and the lights need to be in a certain configuration. Lights change by pressing the button. When a human is not present, Leo uses a fully exploratory approach, going through different actions and noting the state changes that are a consequence of those actions. This learning process is intrinsically motivated. Leonardo has both a motivation to discover novel consequences of his actions and to master the ability to bring about those specific outcomes at will. This method, while reliable, is time-consuming and converges slowly, although the robot is able to serendipitously learn many behaviors of the puzzle box on his own. When a human is available, he or she can guide the robot's exploration by two means: by directing the robot's actions to help him reach relevant states more rapidly,
Leo, try to press the button.
and by drawing the robot's attention to states that are important to solving the tasks the human wants to teach. The human does this through making specific suggestions or labeling interesting outcomes through speech and gesture. The robot also shows facial expressions and other nonverbal cues to communicate its learning process to the human teacher.
Look, Leo, it's white.
Here, Leo learns to note the white light state, which is instrumental to opening the box. When the human leaves, the robot's internal drive leads him to practice the learned action sequence on his own in order to reinforce the task models in an exploratory fashion. At this point, the exploration is not random, but based on the labels and attentive states that were learned in the previous tutorial sessions. Then, the human can return and build on the robot's knowledge to teach Leonardo more complex goals, such as opening the box using the already well-practiced action sequence leading to the white light becoming illuminated. Thus, the robot can build on simpler tasks in order to learn more complex tasks.
Leo, try to move the slider left. Look, Leo, it's open.
After the robot masters these skills through self-motivated practice, the human can request the robot to perform any of these tasks.
Leo, can you make it white? Good, Leo. Leo, can you make it open? Look, Leo, it's open.
Our socially guided exploration approach enjoys the speed, goal-driven, and safety benefits of tutorial learning while allowing the robot to explore, learn, and practice alone. This frees up the human's time and attention and sets the demands from a human teacher at a more scalable and realistic level.